You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal.
And I'm Hattie's co-host, Joe Jack Williams, a partner at Fielding Clegg Bradley Studios.
I can imagine so many applications where we can use earth, where millions of tons will need to be necessary. So let's stop thinking about using earth as a facade, but let's try to use it where it's smart inside the building to regulate humidity, to carry the loads of a floor slab, to infill a structure, to add thermal inertia.
Our guest today is Nicolas Coeckelberghs of Brussels-based BC Materials. BC Materials has developed a reputation for pushing the boundaries of biosourced, geosourced, and urban-sourced materials, in particular transforming excavated site materials into unfired building materials. Upon completing his architecture degree in Brussels, Nicolas co-founded BC Materials with 3 colleagues in 2009. An early transformative experience for the practice was designing and building an earthen library in Burundi. Nicolas went on to do a master's in earthen architecture at Hattie in Grenoble, France. Today, the practice operates as 3 separate entities: BC Architects, a practice of approximately 20 architects; BC Studies, a nonprofit which undertakes research and runs educational workshops in Belgium and abroad; and BC Materials, a cooperative that sells earth-based excavated products. BC Studies has recently undertaken innovative research for the Brussels Metro, exploring ways to reuse excavated site materials arising from a proposed extension to the system. BC Materials recently collaborated with London practice Assemble on Le Magasin Électrique, the transformation of former train sheds into a workshop space for Atelier Luma on the campus of the Luma Museum in Arles, France, and with Carmody Works, work on the bespoke bricks for the Ghent Design Museum, which we heard about in a recent episode with Sean Ricketts. Nicolas, it's fantastic to have you here on the podcast today. We're finally starting to hear about the use of compressed earth blocks in the UK, but you've been at this for at least a decade already. Do you think earthen construction has reached a tipping point, or are we reaching one?
Hello, thank you for the invitation. I have to say that now in the bubble that we are living with BC, I would say yes, but sometimes, like yesterday, I was invited to these events of different enterprises, of big and small enterprises from Flemish enterprises, and then you see that they actually absolutely not busy with sustainability, circularity, and earth construction is not even in their vocabularies. And we see indeed a lot of young architects knowing about the material, not through us, but knowing that actually through other architecture offices. In a way, there is something changing. And does that mean that it's become something that will change the market and will become like a conventional building materials? Then I would definitely say no, it's not yet there. But what I can say is that, we see a lot of increasing demands from public stakeholders willing to use earth as a building materials. And this is, I think, due definitely in Belgium through the fact that we are talking about, in a broader way, about circular economy, how to create products that will not go from cradle to grave, but from cradle to cradle. And of course, earthen building materials are the best for that. There is no any other building materials that I would think of that has better properties than earth in order to be reused and not create any future waste.
I've heard you speak previously about how you kind of got into earthen construction, working in Burundi, and how that kind of formed your kind of approach to it. I just wondered if you could explain a bit how you came to land on earth as an approach to construction and moving away from, some of these typical materials, your steels and your concretes.
When you're a young architect, you don't have a lot of opportunities in the northern atmosphere in order to build something. And then we had this opportunity to go to Burundi, Central Africa, in order to do a building, to actually build a library. And very naively, and I say naively because we had to be naive in order to go there, also thinking that we would do something good, but that was completely not a fact. What we actually gained from that, it's a lot of knowledge. We arrived there and then we saw that it's a country that is not being industrialized, meaning that all materials need to be imported from Tanzania and all the other bigger countries on the borders. What actually made that all those conventional building materials like cement, steel and other plastic materials would be more expensive than the local solutions. We discovered that that people would just build with the resource that they had next to them because labor was less expensive than materials. So we came up to make building materials on site. And then we came into earth. And then we discovered at that moment, look, there is different type of earth, the better one, the less good one. And so that's when we started to dive into documentation about what actually is being already researched. And then that's where we discovered that there were like already decades of research about earthen construction. There was this research that had been done worldwide, books written about how to make testing in order to do soil characterization, in order to make reformulation of different type of soils, in order to improve your mixtures.
So when you came back to Brussels, how did you take that forward?
Yes, and then we come back to Brussels, and then it's a bit a slap in your face. You're back to reality. But this adventure, this project, stayed in our head, and we really wanted to do or to have the same type of process of making architecture, where it's not only buying materials but creating the materials yourself, not building just a contractor but building with the community. And this is how we started to organize workshops. And we did the first workshop in Belgium where we wanted to do ram dirt. So we found in the backyard of one of the colleagues, his uncle that wanted to build a hunting house. And then we decided to do it completely made of ram dirt because there was no ram dirt in Belgium. And we met actually some people with some ram dirt knowledge, this time not from France, but from Austria, Martin Rauch. How did we do that? We said, okay, look, we're going to organize a workshop and that we put it online. And there were many people coming a bit from everywhere in Europe. And then, of course, we couldn't afford to have Martin Rauch coming at that time to come to do the workshop with us. But we had some people that we met there that were also working for him and coming to teach with us. We didn't teach anything because we didn't know at that moment. This is how we actually learned together on the construction site, made mistakes, learned from the mistakes, repaired the mistakes, because otherwise the uncle would be, of course, not so happy that he would have a wall that would erode too fast. And this is how we start to gain knowledge about the material, but also about how to build differently. Because there is no contractor at that time. For sure, there were not any contractor that knew about ram dirt. So we had to gain the knowledge by inviting people and also learning together. And this workshop format was very interesting because then we found a way to create this community that we had like in Burundi of skilled people. And this is how we managed to gain knowledge bit by bit. This is one of the first projects we did in ram dirt. Then we had another project where we managed to implement earth bricks construction with some workshop in order to produce the bricks locally close to Antwerp in Edegem for a public project. So that's a bit a step forward. So we go from private to even public, but with the same difficulties. How do you make the material affordable? And bit by bit, we had new clients and where we could try different stuff and expand our knowledge about earth construction. At a certain moment, we were asked by other architects that said, look, no, we would like to have the knowledge, just the consultancy. We have some budget where you could work as a consultant in order to define a recipe for the project that we designed in ram dirt and maybe train some contractor in order to build it. And so then we started to sell some consultancies where we were actually selling a recipe of a building material and not really the building material. And then we started to have some issues on construction because the material was not yet really standardized. Moisture levels are super important in Belgium, as in the UK, it's raining a lot. So on construction side, we had some issues. And then this is actually the moment we thought maybe you should find a way to actually sell building materials, because that would be the easiest. And this was organically, I would say, the logic next steps, where we decided to spin off our activities of consulting for earthen architecture towards a new company that was BC Materials, where we had the opportunity and the possibility to sell the products also.
I mean, it's an amazing amount of work just to build in earth. So it's fantastic. And the amazing amount of collaboration you've done and thinking about supply chains. It's kind of interesting when you said that you were selling a kind of recipe. When you start looking and thinking about building with earth, what are you looking for? Is it clay? You mentioned moisture. Is it earthworms?
Building with earth means building with soils, but definitely not any organic material. So we're not looking for the worms, and we're not looking for the roots. We're looking for like the very dead minerals. So depending where you are in the world, you have all different type of granulometries, textures, colors available. And the topsoil, what is actually very valuable, but that's not the one that we are using. This is for the farmers, and it's very important to protect it and to keep it well. Until a certain depth, you have this topsoil. And depending where you are in the world, if you are more in the south, you have not so much topsoil. And here in Belgium, it's around at a depth of 80 centimeters that you start to be towards the minerals. And then, depending where you are in the world, you will have a clay soil, or maybe a sandy soil, or a loamy soil, or a gravelly soil for more towards the mountains or the rivers.
So when you arrive on a site, can you describe some of the testing that you do? How do you go about it?
First, when you arrive on the site, you will have to do a characterization of the soil that it's available, looking to the quantities also that are available. It's a bit depending what you want to do. If you want to make one building, or if you want to establish a factory that will sell building materials for the whole city. Then you have to, the first thing, imagine that you want to do a small scale building, you will start to characterize. So you make your hole and you touch the earth. Touching is very important, but you have a series of different field tests that allows you to say, I have maybe a clay soil, a sandy soil, so to define the granulometry, the texture of the soil. And then you will have to define, is this cohesive, yes or not?
Can you do this by feel now, after 10 years? Or do you send this to a lab? Or what do you have to do?
Yeah, it's a good question. Now, after so many years of experience, we can even do this by eyes, but sometimes it's complicated, so we always go to the touching. And then comes the moment where you say, okay, we want to make a material out of it. If we have to add, for example, extra clay because we have the feeling that it's too sandy and it's not going to stick, because what's important to understand is that earth construction is using as a binder clay. It's not cement, it's not lime, it's the clay that's binding the element. But like in concrete, where cement is the binder, you don't need so much of the binder. Maybe between 5 to 20%, depending the type of clay that you have, or depending the type of building material, ram dirt. So it's not that we're looking for clay, we're looking for a right mixture composition of all the ingredients. So imagine that I have a sandy soil where I'm touching the earth, then I will need maybe to add some clay. And that's where you start an iteration of making different samples, depending of the technique that you want to do. If you want to reformulate to do ram dirt, then we will make cylinders of 16 centimeter by 30 centimeter high, or cubes of 20 by 20, depending of if it's a German norm or a French norm. Then you will, for plaster, we will make prisms of 16 centimeter by 4 by 4. And so all those samples will have different recipes. and they will be brought to the lab in order to test the characteristic of the materials and see if they have enough compression strength, or if they have enough tensile strength, or if they have enough abrasion absorption to water. Depending of the materials and the norm that we want to follow, you will have certain characteristics that you have to get, actually. And this is something happening that we do often in the lab. But again, it's depending, of course. The lab is a way to prove what you think is right. Most of the time, we prefer to bring to the lab less samples than too much samples, because it's cheaper. So yes, of course, we gain some knowledge in order to do this quickly and so efficient as possible. And for certain projects where it's not necessary, we don't do it. For plasters, for example, for certain scale projects, you would not have to go to the lab.
Are you kind of issuing warranties and those kind of things to help with insurance and all of that kind of the techniques of building with earth? Is that what's going on in your lab? Is that the output?
Definitely, yeah. No, we're getting so far with BC Materials that our goal is to bring, and this is written in the status of our cooperative, is to bring the market of earthen construction from a niche towards a growing market. And so in order to bring it to a growing market, you need to get away all the thresholds that could be in your way. And of course, certification, it's part of it. It's part of the game. The only thing is that we are slower than conventional building materials that have sometimes way more money in order to invest. But this is part of the game. Although it's not easy, because most of the norms are being written for a lot of materials that are concrete, cement-based, and those norms are not adapted yet for earthen building materials. So there is a lot of work worldwide in order to adapt those norms towards earthen norms.
On that theme of kind of scaling up, then, obviously, earth construction has been around for thousands of years, super low tech. How does it scale up? What kind of equipment are you using? Is it manual presses, or is there some other kind of, how does it get bigger from here?
Yeah, this is exactly where we stand now as the biggest issue. Unfortunately, in Belgium, labor cost is very expensive, and scaling up is, for me, very, very important to do. Why? Because we want to make it more affordable. And this is something we saw, is that our clients with BC, they were very wealthy clients that could afford earth. So we were working on one side in Burundi, where it was economically normal logic to build with earth. And here it's not logic, but it's so unique that they want to put 1,000% more money for a rendered wall. So that's a very expensive way. So how do we lower the price to bring that material to the lower income and to bring it to the normal,
to the market?
Market. Well, that's by scaling it up. And scaling it up in the earthen construction is exactly the same as what we did for the concrete production or for the baked bricks production, is to work with the industry. So in the beginning with BC Materials, where we gained some knowledge, we started to build our mini factory in Brussels, close to the streams of earth that we reuse from construction site. And we were making, for example, our blocks with our mobile press. That was not like a hand press like we had in Burundi, but was already automatic. But to give you an idea of production, we were producing, let's say, 8 tons a day with 2 people.
Seems pretty good.
Yeah, what it's not so bad, but makes the bricks a certain price. And then we thought, okay, this is still, let's say, 300% more expensive than a baked block or a concrete block. So how do we lower the price? And this is how we came with this idea that we actually saw from some colleagues from Switzerland, TerraBlock, that started to do what they called industrial co-working. So they would use almost the same mixture of soil to make the compressed earth block with their small machine, similar to what we had. And then they bring it to a concrete plant where they're used to make concrete blocks, bring them in the machine and produce with the uses existing factory blocks. And there the productivity is more around 300 to 400 blocks a day. with 2 people again. So the price could lower by 200% with no any problem. So that's how we think that scaling it up make a lot of sense.
And are these manufacturers you've approached, are they receptive to this?
Depends a lot. So definitely. So in the beginning, we went visiting actually almost all concrete blocks factory of Belgium. So we went to visit almost all the factories that you can imagine in Belgium, talk with them. Some of them were interested and some of them were very interested. And we decided to work with the one that were very interested. It's interesting now with the industrial co-working. We started last year to do that, and we were going, I think, once every 3 months. And now we are going almost one time in a month in order to bring 300 cubes of materials and then transform it into blocks.
Am I correct that this part of this research into visiting all the block and brick factories was related to a commission you had for the extension of the Brussels Metro? Is that right?
You're right, yes. That was...
Yeah, so tell us a little bit about that, because to me, the fact that the Brussels, you would get this kind of commission from the public sector sounds very hopeful, like a big step forward.
Mm-hmm. Indeed, yeah. That's how actually started, because we filed this research proposal to look into what to do with the millions of tons of earth that would be excavated when they would start to dig the foundations and the tunnels of the metro. We still don't know if the metro in Brussels will be done or not. So the research went quickly into how do we gonna make cheap blocks that we can put on the market, made of mostly secondary resources coming from excavations. Because next to the millions of tons of earth that comes from the metro, you need to know that in an average, Brussels produce 2 million tons of earth from excavations. 60% is not disturbed, so that means that it never saw any human change and is not polluted. So those are very, very easy soils to transform for us. And 60% of 2 million, it's already like a lot. So what is actually the most important is to create more the demand. And this is what we work now the most. We have to actually play chess on all the fronts at the same moment. We have to not only make sure that we can make a lot of blocks, but we have to create this demand. And we organize a lot of workshop and trainings with BC Studies, where we teach to architects how to use earth as a building materials or to combine it with other biosource or reused materials. We train contractors in order to change the habits of plastering, for example, with gypsum plaster to an earth plaster. That's very important. And then last is that we work on making earth brands as mainstream as possible. And this is why on the 22nd of September of last year, we launched our brand called Léém, with the idea of making it as simple, as easy to get, so low threshold as possible as building materials.
So you started as a team of architects and designers, and now you've got all this amazing extra knowledge about materiality and constructions and supply chains. How have your designs developed? Are you thinking about that materiality in a different way? Are you thinking and designing about the constraints of the materials from the outset and looking at that site in a different way?
This is what we, from the beginning, started to do. From Burundi, what I would call as the start of BC, this project was really like looking at constraint. What do we have around us? What is locally available? And I'm not talking about only materials, but I'm talking a lot about also skills. What people can do around us, because it's with them that we will have to do it. This is something that we do a lot within our BC Architects project. It's working with contractors or skilled people that we know, where we have this relation of trust that we built up for a few years, or with people that want to experiment. But now also with the industrial co-working that we organize, it's also looking at skills of human knowledge, I would say. And what makes also that we have sometimes to make compromise in our choices. We sometimes want to go very radical in the materials that we are making or in the architecture that we are making, but sometimes we have to compromise with what we have around us, what makes sometimes our proposals less ecological also, but at least doable. And bit by bit, we start to make some change. So I would rather answer your question by saying, it's really related to what we have around us that would define our architecture, rather than a very clear vision of what we want to change. And the team is also evolving and changing within BC. We are BC Architect Studies and Materials, but we are one big family, I would say. Although we are 3 legal entities with different employees and not so many people work on both at the same time, but we work a lot for each other and we are all working on the same space. We share lunch together, we talk, we go on team building together. We have a very similar type of wage. So that's very important for us, how we also create this change.
So how many are you roughly across the 3
entities? I think BC Architects now it's around 25 people and BC Materials at this moment, because we have this bespoke production in Ghent with Brick with Comrade Rook, where we have also 3 people. We are with 15 now, I think, yeah.
I wanted to ask you a bit about the Luma project in Arles, because it seemed on that one you were looking at lots of other materials as well. What observations do you have about your work on that project? It's a beautiful building, by the way. I had a chance to visit last summer. Really beautiful. Beautiful. The rammed earth, the floors are incredible.
Yeah, this project is one of our, there is a few ones that we have where we call it like the bullseye projects, where we manage to do almost everything that we are wishing for. For us, the bullseye project is when you have BC Architects, BC Materials and BC Studies, and it's here in the middle where it all reaches. So it's not happening every time, but Luma is definitely the latest one where it was possible. On one hand, we have BC Architect doing the architecture, BC Studies organizing a lot of workshops and trainings, and BC Materials creating building materials. But also with a super fantastic team of international architects, such as Assembled, but also the French architects that were involved in the project. A client that it's out of norms, because the client is doing a lot of experimentation where we could work further on. So it was a fantastic journey, being able to design and at the same time prototype, create models, and having a lot of iteration before going to construction sites, and even making possible during construction site to change things within the construction site. But it's also important to be able to do that. This made possible that we have in the end 5 geos or earthen building materials that have been developed by BC Materials. We have a white rammed earth made of dust from sawing of the lime blocks with a waste stream. We have compressed earth blocks that were locally produced, like next to the building sites. We have earth plaster, an acoustical plaster, and a mortar. An acoustical plaster made with also sunflower.
They told me about that.
Yeah, and that's only for the earth parts. Then we have also all the other materials that were developed together with Atelier Luma, going until the door handles in salt, etc. So we trained some local concrete workers to mix rammed dirt, because of course France is very, very rich in craftsman skills in rammed dirt and straw bale constructions. So it was bullseye and full house project, I would say. And I really invite people to have a visit of it, because it's very nice.
Definitely on my list to go check out, I think. Sounds great. So what other kind of materials are you looking into? Are there things that you'd like to use more?
For BC Architect, I think that what we would define as the materials that we use is geo-based, bio-based, and urban-based or reused. So it means that geo-based is everything coming from unmanipulated earth, raw earth, but also stone construction. Bio-based, you have plenty now. You have straw bale constructions, hempcrete, very interesting material because it can be CO2 positive, wood. We like a lot to develop materials, but what we also see now, and that's something we are very lucky here in Belgium, and I suppose it's the same in UK, is that there is more and more companies, a bit like BC Materials, developing other type of materials. And so, for example, in Belgium, we have this company called Isohemp producing on industrial scale hempcrete blocks. And so what again make it more easy and lower thresholds in order to use bio-based and geo-based and reused materials. On the reused scale, we have our neighbors called rotors that are, I don't know if you know them, they are dismantling building materials from construction site, and then they sell them. This is nice because it's, again, they lower the threshold of doing this. You want to do that because it's beautiful looking, it's cool. So that's definitely the materials that we try to implement. Of course, it's in our DNA to develop things. So secretly, we are still developing like oyster shell blocks now for a project also with Léém assembled in Gwangju in South Korea. We are developing also some algae plasters also. But I think mainly what we like most now is also it's to look into what are the materials that have the more potential to have the ability to become upscaled and make a greater impact? Because in the end, I think we are doing that in order to make a change, and we have to make this change quickly. We don't have so much time left in order to lower the temperature and decrease CO2 emissions. So unfortunately, that's the sad part about it, is that it has to go quickly. And so it's nice to make a lot of small scale experiments and make beautiful materials, but now we have to find solutions to be upskilled and talking also the language of the industry in order to have them as friends in the game and not as enemies. I think this is the big challenge, to find the right language in order to have them on board and to be able to make quickly a change.
So this is why you're focusing on the earth blocks now?
Exactly. We were fascinated by rammed earth when we started to gain on knowledge in earth construction, because of course rammed earth is beautiful. But one of the first things that we discovered is that the potential of upscaling earth blocks is way bigger than rammed earth, because rammed earth, it's a very high technical knowledge that you need in order to make quality rammed earth. And due to other technical reasons, I would say, it's difficult to be upskilled and to lower the price to go towards a material that will be market competitive to a concrete wall.
We've talked a little bit about the limitations of the market, and that seems to be changing. But what would you say are the biggest barriers to wider adoption of say, earth blocks? Or
I think it's been scared. There's still this thing that people are afraid to build with earth. This misconception about this is a weak material. Still not understands that weaker doesn't mean bad, but it's probably better for certain applications indeed. And this is very complicated to explain. I have the feeling we manage now to architect, but more and more, definitely younger generations understand that. But still, there is so many people that at the moment that they really have to put their money on the table, they just always choose for the stronger and cheaper solution. It's a challenge to find good ways in order to explain that we have to put the right materials on the right spot, and that weaker in compression strength or weaker in water absorption doesn't mean that it's bad. It means that it needs to be put on the right spot. And this is something that's complicated to explain, yeah.
So education and awareness is what you're saying.
Definitely, yeah.
I've certainly heard lots of talk about the longevity of earth blocks and rammed earth walls. I mean, they're durable. There's lots of examples. How are we supposed to design to make it last a long time? How do we kind of get around those fears? I think people hear weak and think of, it's going to fall apart, but it's not really the case, is it? There's lots of good examples out there.
In earth construction, it's simple. I think the easiest is just to protect it from any water. That's the first thing, because compression strength is still quite very good. Okay, you cannot make skyscrapers, but that's not the point. Even if you make skyscrapers, it's always like a skeleton structure of metal with an infill. So the infill could be definitely in earth, no problem. So it's not about compression strength. I would say the biggest issue. It's really like about the rain that would come to it. So I think for us, what we decided with our brand Léém is to say, look, our materials are for inside. There is no facade. This image of render that is beautiful and making this image of earth construction can be modern, but we have this image of these really beautiful rendered walls, exposed Swiss design. It might be relevant to some places in the world, but in a lot of places where it rains, and it started to be seen that it's everywhere in the world that it started to rain, even in Dubai. So I think we should start to say, yeah, look, don't use earth to make facades. Don't just use it in order to make structures on the inside. We are developing, for example, an earth screed. A screed, for example, is something that will never be in contact with water, that has don't need any compression strength also. So there is a lot of applications within a building that will never be in contact with water. With moisture, it's no problem. That's very good. It regulates moisture in earth construction. But with water, it's a difficulty. So let's stop thinking about using earth as a facade, but let's try to use it where it's smart inside the building to regulate humidity, to carry the loads of a floor slab, to do a lot of stuff, to infill a structure, to add thermal inertia. There is so many applications. And then when you explain that to someone, you cannot use it for outside. That's not interested. And then it's like, but for example, gypsum boards. Do you use gypsum board to make facade? Everyone knows that you cannot not use gypsum board outside. And still, on the day of today, gypsum board is one of the most used building materials that exist. I can imagine so many applications where we can use earth, where millions of tons will need to be necessary. And concrete is used to make concrete blocks to make infill of not load-bearing walls. Why? We fired clay to make clay blocks, to make division walls, non-load-bearing. Why? That could be made of earth. And so I can sum you so many applications where it makes so much sense, but we are sometimes as architects also still focus about this image of this beautiful earth need to be visible also. We need to see it. So that's why I have to say earth plaster, and today is a product that is well sold because it's visible but inside and it makes sense. But earth bricks, I don't know. It's complicated to make mainstream because it's going to be plastered maybe, and so eventually you will not see it. So why should we put a weaker, more expensive building materials that you will not see it? So in the end, every time it comes back, it's about price. Every time.
Well, I think it's price, and I think education. It's about making sure people use the right material in the right place. And you only need one horror story to kind of ruin it. And I think it's really interesting to hear that actually start with the easy wins internally, straightforward. You can do it outside, but you've got to have a think.
Exactly.
Are there any other bullseye projects that you would mention except for Luma?
For the moment, we have less, I would say. And that's okay, because that means that we also have time to do collaborations with other architecture office to work on their bullseye projects. For example, the project that we do now with Coeckelberghs and Atama, where we developed facade brick for the design museum in Ghent. I think it's a very interesting project, a very daring project of the team. They really wanted to make big impact on their project and went really, really far in the development because a facade is one of the most complicated part of a building to go through certification. It costs a lot of time and efforts to convince people that were afraid. This project, I think, when it will be finished, because we are producing at this moment the blocks for it, we just are halfway now. Our machine is super slow. It goes slow, but it goes well. Then I think it's going to be a very interesting project to see also.
Excellent. Is there anything we've had quite a rambling chat about all the different aspects of Earth, but is there anything we've missed? Anything that you want to mention and bring up?
I would just say you just have to dare to use those bio, geo, and reused materials. We just have to do it more and learn more. It's important. Sometimes we're losing time of doing research of things that already been done, and sometimes by just going asking to people that already have developed something to continue to work on their work is making us gaining a lot of time. We had, I think 1 year ago, an exhibition in the cultural center of Hasselt, Z33, and it was called Same but Different. I think it's very typical of what we're doing with BC. Sometimes we're seen as people that innovate, but in reality, what we do is always copying or going further on what people have done, and of course copying with having the right credits and talking about with who we work with. But there is so much work that's already been done where we can continue to work on earth construction. Everything that we do now was already been done. It's just about going further on that and looking around and being open to collaborate with people that do already stuff, because that's how we're gonna go quicker in the solutions.
Thank you, Nicolas. That was just so interesting. I mean, I think you're really pushing things.
Thank you a lot.
Thank you very much.
Thank you a lot for the invitation.
That concludes this materials series of Climate Champions. Thanks for listening. I'd be grateful if you would share this series with anyone you think would be interested. And do drop me an email with any thoughts on future themes or guests you'd like to hear from. Hattie.hartman@emap.com. Thanks. You can find the show notes for this episode at www.architectsjournal.co.uk/podcasts, where you can also catch up with all our previous episodes. If you're enjoying Climate Champions, please subscribe and do rate us on your favorite podcast platform. It helps people find us. Thanks.